Hi friends, today we are going to study about the chemical reactions of amines. So in amines, there are total 6 types of reactions like alkylation, acylation, carbylamine reaction, reaction with HNO2 and reaction with benzene sulfonyl chloride. And there is a sixth reaction which is electrophilic substitution reaction. That's only for aromatic amines. So in this video, I'm going to discuss about the total 5 type of reaction and aromatic electrophilic substitution reaction I'll be discussing in the next video. So let's start with alkylation. So alkylation is a conversion of primary amine. Primary amine is RNH2 to secondary amine which is R2NH. Again from secondary amine we can convert it into tertiary amine which is R3N by adding alkyl halide RX. It means alkylation is a conversion of primary amine to secondary and then to tertiary amine by adding it with alkyl halide. I'll tell you an example. If you take CH3NH2 methanamine as our amine, when you add CH3Cl, this is an example for an RX. The reaction takes place in this way. One hydrogen from CH3NH2 eliminates with chlorine. Chlorine of CH3Cl as HX or HCl. So one hydrogen halide is eliminating. As a result, you get CH3. Here also a CH3 is there, so it becomes twice. CH3 twice NH. Again, it is on reaction with another molecule of CH3Cl. The same way the reaction takes place. This hydrogen gets eliminated with this chlorine as HCl and we get CH3 thrice N, which is tertiary amine. After that, there is no further reaction because of the absence of hydrogen atom with the nitrogen atom. So that you need to study like this. Alkylation is a conversion of primary to secondary and then to tertiary. In this example, we have taken methanamine to N-methyl methanamine and then to N-dimethyl methanamine. So for the IUPAC name, I have already posted a video. You can watch for learning the IUPAC name. I'll be keeping the link in the description box. Next is about acylation. Acylation is also a simple reaction only. Primary amine or any amine, alkyl amine changes to amide RCONH2. So alkyl amine changes to amide. So we can say that acylation is a conversion of an amine to amide. So when you study this reaction, you need to think about the opposite conversion as well. How do we convert amide to amine? That is by Hofmann bromamide degradation, that is by decreasing one carbon which is stepped down, and also by using lithium aluminum hydride. Means either we can use NaOBr, that is Hofmann bromamide degradation, or we can use the reduction by using lithium aluminum hydride. That will be preserving the same number of carbon atom. So in my another video which is the preparation of amines, this reactions has been already explained. You can watch those videos also. I can keep in the link in the description box. So amines to amide by acylation. Let's see how can we convert this. There are two methods. First method is by adding acyl halide. Acyl halide is RCOX. This is acyl halide. Here also the same kind of elimination only. This hydrogen gets eliminated with this halogen as HX, which results RNH. After NH you write this COR part. COR. This NHCO is the amide group. So the product is amide. RNHCOR is amide. This is one of the method. Second method is this. Instead of acyl halide, you can add anhydride. Anhydrides are having the general formula RCO twice O. This is anhydride. I'll show you the reaction clearly because if you're writing RCO twice O, we won't be able to understand the way of reaction. I'll show you. See once more, RNH2 is in reaction with RCO two times. So once more RCO and these two RCOs are connected through an oxygen atom. This is the complete structural representation of anhydride. During the reaction COO, there are two bonds but one of the bond will be breaking. So one part is RCOO, another part is just RCO. So to RCOO, one hydrogen from this RNH2 will be eliminating, which means it is connected with the oxygen atom. As a result, we get RCOOH, which is acid, carboxylic acid. That is the byproduct. And the main product is this, which is RNH. We write RNH. That connects with the second part of this anhydride, which is COR. That is amide. So we get amide and a carboxylic acid. In the previous reaction also we got the same amide. You see RCONH or only in the previous reaction. Only the difference between these two acylation reactions is the byproduct. In the first reaction I said HX is a byproduct. It's just an acid, but in the second reaction it's a carboxylic acid. So to eliminate the carboxylic acid, if the reaction is carried out in pyridine is a base. We know that when a base reacts with an acid, there will be neutralization, so that the product concentration will be decreasing from the reaction vessel. So as per Le principle, the concentration decreases in the product vessel so that the speed of reaction increases. So there is a reasoning question connected with this topic, which is acylation is carried out in presence of pyridine. Why? Because pyridine is a base and this pyridine reacts with carboxylic acid and there will be neutralization so that speed of reaction increases. This is how we can understand. Got it? So one or two example I can explain. You see CH3NH2, CH3NH2 with an acyl halide like CH3COCl. So this hydrogen and this chlorine gets eliminated. We get CH3NH and then COCH3. Got it? And the same methanamine I'm taking, CH3NH2. This time we can add an anhydride like acetic anhydride. CH3CO twice O. Got it? So CH3NH, again the same kind of bond breakings, so that we get the same product. Only the difference between these two is in the first one, HCl is a byproduct, and in the second one, CH3COOH, acetic acid is a byproduct. Okay, so here there is an important conversion I'll tell you. That is, if you take CH3NH2, which is on reaction with C6H5COCl, which is benzoyl chloride. So after getting eliminated with this HCl, we get CH3NHCOC6H5. It means the CH3NH and this part and the C6H5CO part gets attached. And this product is called the acetanilide. So that's a common name of this product. So this conversion can be asked like this. How do we convert methanamine to acetanilide? That is one of the easy conversion. And one more example which is helpful for you to the conversion. C6H5NH2, which is aniline. Aniline on reaction with the same compound, which is C6H5COCl, benzyl chloride itself, you will be getting C6H5NH. This hydrogen and this chlorine gets eliminated and you get after this COC6H5. This product is called a benzanilide. Benzanilide is produced from aniline. So how do we convert methanamine to acetanilide and aniline to benzanilide? These two examples are like coming as conversion, and also this kind of question can be asked as the complete reaction type. And also if you take a secondary amine, for example if you take R2NH with RCOX, you will get the same kind of reaction. HX gets eliminated, you will get R2NHCOR. Noted. So even primary and secondary amines are having same kind of reaction by eliminating HX. But if you take a tertiary amine, R3N, when you add RCOX, how hydrogen gets eliminated with X? There is no hydrogen connected with an hydrogen atom. So in this case, no reaction. So there is another reasoning question. Acylation doesn't take place in tertiary amine. Why? Due to the absence of hydrogen atom attached with the nitrogen atom in tertiary, there is no acylation. So these kind of reasonings also you have to learn in this topic. So I said about in this topic, complete the reaction type question can be asked, or sometime conversion in this type, or like reasoning. Reasoning, there are two reasoning why pyridine, role of pyridine, and also acylation is not there in tertiary. These three, these two conversions also. Then carbylamine reaction. Carbylamine reaction is a conversion of a primary amine. You see RNH2 is a primary amine on reaction with the CHCl3 and KOH, which is chloroform and alkali. When you treat it with this reagent, you get RNC. RNC is alkyl isocyanate, which has an offensive smell. So this reaction we studied in distinction test. So distinction test, or how do we understand the presence of primary, secondary and tertiary amines? A detailed video already I have uploaded. You can watch those videos also. So under the chemical reaction, if you are talking about the carbylamine reaction, we can say that carbylamine is a conversion. Carbylamine reaction is a conversion of an amine to isocyanate. So the reagents using in these reactions are KOH and CHCl3. So by CH3 or by C2H5, even with the C6H5 aromatic primary amines also, we can do the same reaction. The condition is always only for primary amine this reaction takes place. For secondary amine, tertiary amine, no carbylamine reaction, or we will not get the characteristic oxidation. So to distinguish between primary and secondary, we can use carbylamine reaction. Next is with reaction of amine with HNO2. HNO2 is NaNO2 and HCl. Is a combination of sodium nitrite and HCl, which is also called a diazotization. So when you take R and H2 primary amine and do the diazotization reaction, this NH2 group is replaced by N2 plus Cl minus, which is diazonium salt. This also comes under the distinction test only. So you may watch the detailed video, which is alkyl diazonium salt. And we studied this alkyl diazonium salt is highly unstable, so that whenever it gets produced, it immediately change it into alcohol. So we say that this is a conversion of, this is how you have to study. HNO2 reaction is a conversion of an amine to alcohol. So whenever you get a question to convert in this way, amine to alcohol, or sometimes from alcohol to acid or aldehyde also can be prepared. So amine to aldehyde or amine to carboxylic acid, now amine to alcohol. This path you can follow. So alkyl amine to alcohol. But this reaction is only for alkyl amine. This alcohol preparation is possible only for alkyl amine. Why? Because if it is aromatic, for example C6H5NH2, when you do diazotization, this NH2 changes to N2 plus Cl minus, which is also a diazonium salt only, but that is benzene. Benzene is aryl diazonium salt. And aryl diazonium salts are highly stable due to resonance. So that itself is a vinyl product. So it will not change it into further product until and unless if we provide another reactant to that. So that is stable. So this is how we can distinguish between aliphatic amines and aromatic amines. So distinction test you have to study separately. Got it. Now benzene sulfonyl chloride. Benzene sulfonyl chloride is this C6H5 S double bond O Cl. This is benzene sulfonyl chloride. When you add a primary amine to this H and Cl gets eliminated and you get RNH S double bond O C6H5. This is how the reaction. So reaction, when you understand how the elimination is taking place, then by joining the reactant you will be getting the product. So no need to by heart any of the reaction, just understand in this way. R2NH, if it is secondary amine, do the same reaction, benzene sulfonyl chloride. We studied already the common name of benzene sulfonyl chloride in distinction reaction. That is Hinsberg reagent. Benzene sulfonyl chloride is also called a Hinsberg. So this test is called a Hinsberg reagent test. Okay, so here also H and Cl gets eliminated. You get R2N. After N, you write S double bond O C6H5. But at the same time, when you take R3N, it's tertiary amine. There is no hydrogen atom, so this reaction is not possible for tertiary amine. Another reasoning question. Hinsberger reagent test is not possible for tertiary. Why? Due to the absence of hydrogen atom attached with the nitrogen atom. It's only for primary, secondary. Tertiary, no reaction. So this test is used to distinguish between primary, secondary and tertiary amine. So that is the application of the fifth reaction. The fourth reaction, what I said is, it is used to distinguish between alkyl amines and aryl amines. And carbylamine test is used to distinguish between primary, secondary and tertiary. So these are the important reactions of amines, especially here I am talking about only alkyl amines. But aryl amine, there is a special reaction which is distinction. Other than distinction test, we can go for electrophilic substitution reactions. So in detail, in the coming videos, I'll be uploading those reactions. And here we'll see a quick mind map to understand all this. We start with the RNH2. We have a primary amine. We can change this primary amine to R2NH, that is secondary amine, by adding RX. And the secondary amine you can change it into R3N, tertiary amine, again by adding RX. And then when you add RCOX, acyl halide, it changes to RNHCOR, amide. Not only acyl halide, if you go for RCO twice O, which is anhydride, you'll be getting the same product, amide only, RCO, RNHCOR. Then when you add CHCl3 and KOH, which is chloroform and an alkali, you get RNC, alkyl isocyanide. And then when you add NaNO2, which is sodium nitrite, and HCl, which is diazotization, first you will get a diazonium salt, but it is unstable, so finally it changes to ROH, which is alcohol. And then we studied if there is a primary amine, you add a Hinsberger, which is C6H5, S double bond O Cl. We'll be getting RNH, then S double bond O C6H5. So today I discussed about these kind of conversions, primary to secondary and then to tertiary. These two are amine to amide. This is amine to alkyl isocyanate, amine to alcohol, and then Hinsberger reagent test. In between, I have discussed about some of the reasoning type questions and also some important conversions and some distinction test. For the distinction test, you have to see the detailed video. So I hope today's class is understood. So you can watch more videos for the continuous topics. Thank you.